So I took the lithium battery out of this little RC car, and then I replaced it with a single supercapacitor, 2.7 volt at 50 farad. I even added a simple little solar panel, and now that I'm close to, I'm going to say it's charged, and then close to a full charge, and now I'm going to take it to the hallway and see how long it lasts. I'm going to flip the on switch on the RC car. Alright, and let's take it for a drive. So this is going to be a purely supercapacitive RC car, no battery included. It is complemented with a single solar panel. I tried a 5-volt boost at one time, and it just drew more current and the car didn't move so fast. So let's go ahead and start the timer. Alright, so timer's going. Let's take it for a drive. I'm going to do my best to try to drive this and record the video at the same time. So once again, this is a purely supercapacitor RC car, and it's using one supercapacitor, which I am tempted to put a couple more in parallel to get a longer longevity or runtime. I haven't investigated the solar panel, if the solar panel is contributing to anything to the supercapacitor at this point. Right now I'm in ambient room lighting. That is for another video when I'll do a continuous run with the solar panel alone without the supercapacitor. So once again, this is a purely supercapacitor RC car with no battery included. Now I can put another supercapacitor in here with a higher capacitance, 100 farads. I could also put these in parallel to get a higher capacitance, which would give me a longer runtime. If I put them in series, it'll reduce my runtime but give me a higher voltage, so it'll just be more of a performance acceleration than a duration. And it's still going. And I'm going to loop back here. So I am driving this little RC car in the USF Research Innovation main gallery. And so I've already looped around. And as I see the timer on my phone, we've been going for about 3 minutes on this little single supercapacitor. I'm going to try to get some sunlight here. Maybe the sunlight can assist the supercapacitor. Great thing about supercapacitors, they're immune to thermal runaway. If you crush it or you overcharge it, it's not going to catch on fire. If you put it in a hot climate, the extreme hot temperature is not going to explode, unlike a lithium battery. If you do crush, it explodes. If you put an extreme hot temperature, it explodes. So supercapacitors, the downside is that they discharge really fast. Unlike a battery, can maintain constant power for a longer duration, but supercaps can also charge as fast. So when you use supercapacitors with energy harvesters such as solar panels or wind turbines, you can actually, in some applications, get away from using a battery. So it's just a temporary or interim fast charging device that can store energy or charge really fast and store energy for a little bit of time and power something, while a primary power like a battery or something is in a transitional state or an interrupted state. So it looks like my little RC car is now slowing down here. If I check the specs, the original lithium battery, which is rated at 100 milliamp hours, is runtime is rated at a maximum of 10 minutes. But right now with the single super cap, I've been driving it for about 5 minutes. The advantage of this is that this super cap charges faster than its original battery and can almost perform as much as the original battery as well. So I can put a couple more supercapacitors in parallel to get a longer duration or longevity of this run. So that's it for this video, and thank you for your time.